Welcome back. In this video, we'll learn to determine how many electrons are held within each shell and subshell from the periodic table. We'll also describe the shapes of the s and the p orbitals. As we've seen already, the periodic table is organized into periods and families. The periods correspond to what are called electron shells. Each shell has the same energy level, and the farther those shells are from the nucleus, the higher in energy they are. The arrangement of the electrons around the nucleus can be described using quantum chemistry. And this describes that electrons are held in atoms, but only at specific energies. You can't have any energy. You must have very specific values. And we say that they are quantized. Electrons are organized according to their energies into what are called shells. And each shell is labeled with an n value, where n could be 1 to any integer, 1 to infinity. So the higher the n value, the higher the energy, and the farther that the electrons are from the nucleus. We saw earlier, using Coulomb's law, that when you have an attractive interaction with a positive and a negative particle, that the closer they are together, the lower their energy is. And the farther they are from each other, the higher the energy is. So the same can be applied when thinking of an atom, where you have the positively charged nucleus in the center and the negatively charged electron around the outside. There are two depictions of this scenario here. This one is looking at a single electron going between the different shells. And we can see that the farther away it is, the higher the energy is. On the left, we have what is referred to as the Bohr model, B-O-H-R, named after Niels Bohr. And this is depicting the electrons circling around the nucleus in these orbits. Again, it also depicts that the electrons can only be at certain distances away. Now, it turns out that the Bohr model is not 100% correct, but it's good enough for our purposes in this course. The shells of an element are divided into subshells. The subshells are labeled in order with the letters S, P, D, and F. And so the first shell consists of the first row of the periodic table. And this has one subshell. The second shell consists of the second row of the periodic table, and it has the 2s and the 2p subshell. This continues on and on. The third shell has the 3s, 3p, and 3d, and the fourth shell, the 4s, 4p, 4d, and 4f, and it continues on and on. So it's important to note each of these periods is representative of the shells. The shells are designated into their subshells, S, P, D, and F. And also that the width of these different blocks, the S block, the P block, etc., indicate how many electrons can be held within that subshell. For example, you see that the S block is 2 units wide. It can hold 2 electrons within each S-type subshell. The P block is 6 wide, and it can hold 6 electrons. The D block is 10 wide, and so it can hold 10 electrons. And the F block is 14 wide, and it can hold 14 electrons. Now, where are these electrons held? They're held within what are called orbitals. Each orbital holds 2 electrons within them, and their shape and size depend on various characteristics. For example, the s orbitals are spherical in shape and the p orbitals are dumbbell in shape. Now let's practice on a problem similar to one that you might be asked to do yourself. How many electrons can the second shell hold? Remember, each shell is divided into subshells. So in order to solve this, you want to determine which are the subshells involved. And then when you look at the periodic table, you can see how many electrons would be held within that subshell based on the width of that subshell. So the 2s subshell is right here, and the 2p subshell is right there. And together they make up the second shell. The 2s subshell is 2 blocks wide, so it can hold 2 electrons. The p block is 6 wide, so they can hold 6 electrons, which means that we have a total of 8 electrons. That's it for this video. Thanks for watching.